Hello, this is the Debit Coder. In this video I want to talk about placement new operator. I'm going to enhance my vector class in order to allow it to instantiate and destruct class objects as they're allocated. So let's do template class. I'm going to specialize this vector for a new type. Let's just call it some class. I'm going to include a header for that, some class.age, let's say. Okay. So one thing I need to do here is I need to say when it destructs, I'm going to be iterating through all of the elements, if any exist. I'm going to call the destructors manually. So size t, I equals 0, I less than, I think it was mst count. Okay, sti plus plus. Alright, I'm going to say lbt data at position sti dot, I'm going to say tilde for destructor t, whatever the type is. So that should call the destructor on the element to that position. Now I need to actually make it so that the element is actually instantiated, right? So right now I'm just copying some value over, assuming it's a primitive. So what I need to do is say new. I'm going to do at the address lbt data mst count. And I'm creating a type t, and I'm initializing that with the value t. So imagine I have some class, I don't know, let's call it some class, right? Se for some class equals, it's going to be new, some class, and that takes some type, some value, right? Put 1. So you can imagine right here what I'm saying is this part of it, but I'm just ignoring what it returns because I don't really care. I already have the memory, but I'm just constructing this at that address. And this argument right here is like the one right here. That's all that's happening. Okay. Let's do that. What else? I'm going to actually make it so that I can move back as well. Looks like I started to make that before, but I never actually finished that. So let's take that over here. Okay. Alright, let's get rid of those. And I will actually, in this case, say standard move. I'm going to call the move constructor from this. Alright, now let's make that class. Some class.cpp. Let's say some class, make a constructor. I actually don't want a default constructor, but I will have one that takes like an int, let's say. Okay. That's what I'm going to call it. Okay, that's my constructor. My destructor is just going to... Actually, I'm going to think about that. I need to show that it's working. So I'm actually going to make it so the constructor prints out what it's doing. Yeah. So let's say we include some class header. So I'm going to make a header for this. I'm also going to include iostream so I can print out. So standard cout. I'm going to say pretty function was called with value. I'm going to say whatever was passed to us and stored. So mi. That should work. And I could do that for the destructor as well. I can show which variable was actually added to the class when it destructed, so I know which one's destructing. So let's do a copy constructor, const some class, class reference. Okay, do the same thing here. We'll do a move constructor, some class old. Okay, let's say mi equals old.mi, so copy the integer over. Okay, mi equals old.mi. Okay, now I need a assignment and copy operator overload. Some operation, what am I saying? Some class operator equals const some class reference old. Some class, going to return a reference to that. Let's return this, I can chain it. mi equals old.mi. Boom. Okay. Now I can almost copy this verbatim and paste it, so I'm going to do that. Well, I have to change this. Needs to be 2% right here. Anything else I care about? I don't think so. No matter how it's constructed or assigned at this point, or when it destructs, it's going to say something now. That should be enough. Okay, so now I know some class.h. Drag not once. It's not defined. Some class header. We're going to define it. Some class header. And if. Okay, so we have class, some class. Private, we have int mi. Public, we're going to have the constructors. Default constructor is deleted. But we do take one that has an integer. So I said int I. Some class. It's going to be a destructor. And some class. Const. Some class reference. Oops. Okay. We'll do the move constructor, and then we have two more. We have the operator equals both of these. Equals, okay. So copy assignment, move assignment, move constructor, copy constructor, destructor. This is going to be our only constructor we can use. So constructor. Default constructor doesn't, you're just allowed. Okay. Cool. So now we have ways of constructing it, and each one of these is going to basically tell us about what happened. So now I need to say in my test application, I'm going to include that header, and inside of my vector, I think I already included that, right? Yeah, I did. Okay. So, inside of my test application here, I'm going to add that header. So let's do that. Include, it's going to be some class.h. I'm going to take the code I already have in here. Let's just stick that in a different test case. Void test user 2 or something. Okay. Let's return something looks like. So return 1. And whatever. Okay, so we have vector of some type. It's going to be some class, vec. Let's construct it with 1, 2, and 3 using the initializer list. And as this constructs, each one of these is going to call some kind of constructor. And then when it destructs down here, it's going to call the destructor. And when that happens, it should alert me. So let's try and test that out. G++ test.cpp. We're going to include vector.cpp and some class.cpp, and the output's going to be test. And looks like some mistakes here. Bit ceiling isn't in there. That's kind of an issue. That needs to be standard C++ 20. Standard equals C++ 20. Okay, so what do we have here? Expected unqualified ID before if. This is in vector line 106. Okay, let's test that out. 106. Right, okay. That's a problem. And also, if I go to vector.h, move back. Yeah, I never actually uncommented that. Yeah. Let's try it again. What else do I have going on? So 106, incapacity was not declared in the scope. Okay, I think I know why that is. Vector.cp, 106 I think it was. 106. Yeah, I never actually said it comes from the vector class of type T. Okay. Try now. Okay, 110. Return statement with a value and function returning void. Fair enough. It should be returning a bool. Vector.h. Move back. Oops. Okay. What else do we have going on? Some class, line 22, no declaration matches this. I don't think I actually specified the class name before it, did I? Line 22. Yep, okay. Some class header. And for the assignments, I need to make it actually return a reference to the class itself so I can chain. Okay. Let's give it a try. What do we have here? Okay. We can see it actually constructed it, which is cool. And then we're calling the copy constructor, or sorry, the, yeah, copy constructor, not the copy assignment. Okay. So it constructs these values, and then it copies them into that object. Okay. And then the copies are getting destructed, and so are the actual values themselves. So the reason that's happening twice, just to show you, vector.cp. If I go into, where is it? Right here. So it's going to construct a new object here, and it's going to copy it into the memory address right here inside of this array of elements. And this copy is going to get deleted, and then that's going to call the constructor. But then also inside test.tpp, when this goes out of scope, it's going to hit this and destruct this vector object. And the vector object, if I go into the part where I see free here, it's going to call the destructors for each of the elements. So that's why that's happening. Let's try a different method here. Vector, not vector, I want test. TP. So instead of pushback, you know what I'm actually going to do? I want to do this. I'm going to say vector TP. I'm going to say move back. Let's just make them both called pushback. And I'm going to say vector.h move. Make it also push back. Because they take different types of arguments. This one takes something mutable that I can move. Let's see what happens. Okay. Now it's still calling the copy constructor. Interesting. That's even though I'm explicitly calling move on it too, I think. Move. Move again. Yeah, it is calling standard move on it. That's interesting. Although, if you think about it, test.cp, what I'm actually doing here is I'm passing these values to the constructor. And because the constructor does take a number, it is implicitly convertible into that type. So what I could do then, I suppose, is something like some class, right? Some class. Yeah. Okay. We're still getting that const. Okay. And just for fun, what if I do some class array that? I guess I could say 3. Then say equals. I'll say 1, 2, 3. Let's do sc array 0, sc array 1, sc array 2. What's that going to do? Yeah, it's still going to call the same constructors, looks like. Interesting. Can I do this? Actually move each object. Let's try that. Aha! So now it is calling the move constructor. I don't know if that's actually advantageous, but that's interesting nonetheless. And what if I do this? What if I do vector type some class vec, and I actually initialized it with standard move from the actual type, the number that I'm storing. Like, surely this won't work. Yeah, it doesn't. I didn't expect that one to work. But I could do this, you know, some class 1, right? That should be valid. Some class 2, sum class 3. What do we get? It constructs it, then moves it, and it constructs it, then it moves it, it constructs it, then it moves it. Funny. That's even worse. Look at that. Anyway, lots of fun stuff we can do there. I'll leave that there too, just for fun. Let's get rid of all that. That's annoying me, that little cap there. Okay. Anyway, so that's how you can do that. Now at this point, if you look at my vector, I'm still using calloc for the initial allocation, and as I need to resize, I'm still using realloc. And this should be faster than doing something like new brackets and delete brackets. Every time you reallocate, you know, deleting it. And after that, actually what I would do then, if I needed to expand it instead of reallocating, I would allocate a new array, so say a new one, say a new buffer. This is like our original. And I would say new buffer is this, and I would like copy into new buffer, and I would delete original, right? I would have to do that. So at some point there's like double memory being used until I copy it and delete it. It seems really inefficient. Although I guess that's kind of what happens behind the scenes with this too, in a way. Because it would have to allocate a new block and then move stuff over there transparently. Either way, I don't know. This is a valid way of doing it. I'm at least adding elements in a pre-allocated block, which is nice. This is less work too than doing it with the new and delete like that. If anyone has any comments about this or thoughts, criticisms, I'd be interested in hearing that actually. Because this is the first time I've actually tried using the placement new operator. There's also a placement delete you can use, which I think you have to do something like, what is it, operator delete, and take the address. I can't remember exactly. There's something funky with that. I was just looking at that a second ago. Yeah. It's like it's that, something like that. Anyway, I think I'll leave some notes in the video description. But yeah, if you like what you saw, please give it a thumbs up, maybe consider subscribing, and please do leave any feedback you have. I appreciate it. And that's going to do it. I'll catch you guys later. Have a good day.